Okay, so last video we decided to use improper integration to solve this question that asks us to evaluate the integral of e to the minus x times sine x dx from 0 to infinity. Alright, so now that we've chosen to use improper integration, let's set up the integral using the improper integration definition. So that involves taking a limit as t goes to infinity from 0 to t. Notice how we replace the infinity sign by t and then take the limit as t goes to whatever the value at the boundary was, either infinity, minus infinity, or a singularity. So we write the remainder as the same. Alright, now what? Well, what this is saying is it's telling us to evaluate this integral, then take the limit afterwards. So the next step would be to evaluate this integral, integral of 0 to t e to the minus x sine x dx. So we're going to do the same thing we did in the previous video and try to figure out which technique is the best to use to evaluate this integral. Alright, so again we have our tools and techniques, and there's analytical and numeric, improper integration, integration by parts, inverse, trig sub, partial fraction, expansion, and our trig sub. Okay, so looking at these, we can already cross out analytical and numeric for reasons that were described in the previous video, as it's not very practical. Improper integration was the technique used to initialize or to help us start the problem, but it's not going to be the technique used to help us finish this particular integration problem. So that's out. Integration by parts, this seems promising because looking at the expression we can see that we can obtain some sort of reduction formula to solve the integral, so this is promising. Inverse trig sub, again there are no inverse trigonometric functions. Partial fraction, there are no rational functions. And trig sub, subbing in something for the sign will not eliminate the exponential and will not simplify the problem that much. So it seems like integration by parts is the method to use. Alright. Okay, so using our integration by parts, we need to set up our parameters. So it seems like our v is equal to e to the minus x. That means our dv dx is equal to minus e to the minus x. And then our u in this case is equal to sine x. Sine x dx is du actually, and then our u is just the integral of that, which is minus cosine x. Okay, so we set up the integration by parts by the definition, so we get our integral of v du equals uv minus integral of u dv, and that leaves us with our integral of v is e to the minus x, du is sine x dx, and let's not forget about our boundaries. So this should be the original expression, which it is equal to our uv, our u is minus cos x, times our v is e to the minus x from 0 to t, minus our integral of u in this case is minus cos x multiplied by our du, which is sine x dx. So this times sine x dx, and I'll finish this and write it much neater in the next video. Thanks for watching.